All right, finally, last part of blood. I know, seems like forever. Well, not for you guys, but seemed like it took me forever. Okay, so the last thing I'm going to talk about is comparing blood clotting versus blood clumping. Blood clotting occurs because of a process called hemostasis. And within hemostasis, there's a process called coagulation. So technically, blood clotting is coagulation. Okay, in hemostasis and coagulation, the role here is to prevent blood loss. In blood clumping, this is called agglutination. And this is actually an immune response. It's one of many types of immune responses, but it's an immune response where basically you are going to remove foreign cells. In this case, it's foreign red blood cells, okay? So there's like a clear division between these two processes. And I know I have coagulation over there and hemostasis, but let's go over agglutination because maybe, no, we'll go over hemostasis and coagulation first. So hemostasis is like this. I'm really going to try my best, you guys, to draw out a blood vessel, okay? That's my blood vessel. Basically, you've got this tear or opening in your blood vessel. And let me do like 3 of them so I can show you what's going to happen in each of the stages here. Really should have just put a picture in here, but I didn't really think about it until right now. So that's my next blood vessel, okay, with my tear. And then that's my other blood vessel, my tear. It's all the same blood vessel. It's just I'm going to show you in three steps, okay? 4 steps. So number 1, you break open a blood vessel. I promise I'm not going to abbreviate. So when your blood vessel is broken, you're basically losing blood. That's what's happening, okay? So the second step here is you have to prevent blood loss. And to do that, the first thing you're going to do is vasoconstriction. What vasoconstriction does is you're going to have a layer of smooth muscle in here, right around the opening of the blood vessel, and that's called the lumen. So just imagine blood spilling out. When you vasoconstrict, you're going to get a smaller lumen. So what that means is your blood vessel opening gets smaller so that less blood flows through it and you lose less blood. So you write some extra notes there, okay? Then essentially the third step, essentially here the third step is going to be a plugging up the hole. To do this, the platelets, which are, remember, those really tiny cell fragments, those tiny cell fragments are going to get stuck in the hole because there'll be some fibers here, some collagen fibers that basically unwind because you have that hole right there. So platelets are going to get stuck together with collagen. And this is going to significantly reduce blood flow. So like maybe you have just plasma flowing out instead. So like maybe you just have a little bit of plasma flowing out instead. So it's not complete blockage. So the complete blockage, you have to do coagulation. Okay. In coagulation, you're going to use fibrinogen. Fibrinogen is going to go through this chemical change where you create fibrin. And fibrin is going to be soluble fibers that are inside the blood. So you basically create this much bigger netting. Just remember, you have some platelets here and some collagen fibers. Just like that. Oops, sorry, I was looking for something. And then because you create those, the fibrin, essentially what ends up happening is you end up plugging this hole up even more because of red blood cells and because of more platelets and because of white blood cells. So now all the formed elements are going to end up blocking the hole. When they block this hole, now blood is not going to leave, and you basically kind of created something like a scab. It's not the same thing, but you've created a wall so you don't lose blood, and then you can start to repair tissue. So like number 5 is tissue repair. Okay, so that's what clotting is. This is clotting. Your blood vessel can cause clotting even though you don't have a ruptured blood vessel. In that case, it's usually a deep vein thrombosis, and you get a clot in your blood vessel that's going to obscure or prevent blood flow from occurring. That means it's going to stop blood flow. We'll talk maybe about that when we get to circulation. Okay, that's a bad thing. In this case, it's helping you not die. When you do it when you're not dying, then it's bad. So how is this different than clumping or agglutination? Okay, so let's just draw out our red blood, our blood vessel here. I'm just going to make it bigger. Inside of our blood vessel, we're going to have red blood cells. And, you know, I'm going to make those smaller because I'm going to make this a big blood vessel. So let's say we have a big blood vessel. We have these red blood cells, okay, all in here. And remember, they're going to have antigens on their surface. So let's just say we have some A antigens here, kind of going along with what our patient had originally, which is A negative. And their antibodies are for B. So we've got these B antibodies floating around. Okay. You decide you're not going to follow blood compatibility protocols. I should actually erase this. I'm sorry. I'm going to give you a couple of A's here, like 1 or 2. That's your patient's blood type. And then we're going to give them new blood. So when we give your patient new blood, they've got these antibodies floating around that are anti-B antibodies. And you decide you're going to give your patient B negative blood. So now you can see, oh man, that's going to attach right there. And oh man, that's going to attach right there. And you'll have all of these nice antigens that are going to attach here to our antibodies. Like you're going to have more antibodies coming into the area. They're going to attach together. And they attach all these cells together. Basically, they're going to cluster or clump them together. And when they do, that creates a clump in the blood vessel. That clump is also going to prevent blood from moving. But what ends up happening is white blood cells will come to the area. And they are going to destroy the red blood cells. And when that happens, you actually release cell contents, including heme and parts of hemoglobin, and that drags all through your blood vessels, and that's what kills you. Okay, so that gets broken down. and that can end up killing you. So I want you to see the difference. The clot is all formed elements. The clump is just because you're binding all the red blood cells together. All the bad, not the bad red blood cells, all the red blood cells where antibodies have attached to them. Okay? This is an immune response instead. This is a response where basically the body's trying to get rid of something foreign. So you see the difference between clumping and clotting. Make sure you understand the difference between these two different processes, okay? I think that concludes blood. Sorry, I don't have any objectives or like summaries. I just got to get through making a couple videos for you guys here in the beginning, okay? So come see me if you have more questions about anything regarding blood.